This video is going over the workbooks from Geometry's lesson 16. So 16.1, number 1 in the upper left corner, Jordan welds a triangular gusset to strengthen the frame of her recreational vehicle. She compares it to another gusset, I think I'm saying that right, maybe, as shown in the following figures. So there's triangle ABC and then triangle DEF, and then on the right side it says, what additional measurements must Jordan know to use the angle side AAS congruence theorem to prove that the two gussets are congruent. So she wants to use the angle side congruence theorem. She already has like one pair of corresponding sides that are congruent. She has side AB and side DE that are both 5 inches. Those are corresponding, they're congruent. So she already has like the S part of that theorem. Now we need the two like angle parts, the A, and they have to be angles that don't have the side like in between them, because we're using AAS, so the side should not be included between the two angles. So if we look at like kind of the answer options, that honestly eliminates like two of our possible angle measurement, or two of our possible answers, because we definitely need to find like two more angles. So if you look at the first choice, one of the things is that the angles are 35, so that gives us another angle. And then the other like new fact is that the two segments are 8 inches. We don't need another side. We need two angles. So that doesn't give us the two angles that we need. So that one is just an answer that we can eliminate right off the bat. And then same thing with the last option. So down here it gives us the two angle measurements of 87 degrees. And then it gives us that those segments are both 8 inches as well. Again, we don't need any more sides of these triangles because we're trying to use the angle side. So I already have one side. I need to find the two angles now. So now between the two options that are remaining, the first one says that angle ABC, which would be like this angle right here, and angle DEF, which would be this one right here, measure at 87 degrees. Remember that like when you're writing angles, the vertex of the angle goes in the middle, so that's why B and E were the vertices. And then the second one says, or the second part of that answer says the angle ACB, which is this angle, and then angle DFE, which is this angle, measure 35 degrees. So let's see, these would both be 87 degrees, and then these would both be 35 degrees. So that looks like it would totally work. So I have to have two angles and a side that's not included to use the angle side. So this is angle, and then the non-included side up there. So that one's going to be our correct answer. I just want to talk about why the second one, or I guess the third answer choice, doesn't work, because it looks really similar to this one. So I'm going to erase some of this and start from the beginning of that one. So at the start, it says angle ABC and angle DEF. So ABC is this one and DEF is this one, are both 87. So that's the same start as we had in the beginning of our like second choice, the correct answer. And then the second pair of angles that they group together says angle BAC. So that would be this angle right here is 58 degrees. And then angle EDF. So that would be this one right here is 58 degrees. And then we already, of course, know that like both these segments are included. So the information that's given to us in this answer is technically enough to say that the triangles are congruent, but it doesn't answer the question properly. So the question was like, what additional measurements must Jordan know to use the angle side congruence theorem? And remember that the order of the theorems matter. So since it's like angle, and then side last, that means that the side is not supposed to be included in between the two angles. This like information that we have from this answer would be enough to use angle side where the side is in between the two angles, because you can see like the highlighted side, that yellow side, is in between the two angles that we know, but we don't want it to be because we want to use angle side. So that was that second option where angle ABC was 87, DEF was 87, and then ACB was 35, DFE was 35, and then we knew this side that was not in between those two angles. So that's why it was the second choice, even though the third choice is enough to show that they're congruent, just didn't properly answer the question. 16.2 number 2 is a proof, so use the information in the diagram to prove that triangle HIJ is congruent to triangle LKJ. Match each statement in the proof with the correct reason. Notice that the reasons are on the left and the statements are on the right. So normally in proofs we put the reason on the right, or sorry, I said that backward. Well, I said that right, but I start in a weird order. So we put the statements in first on the left side, and then we put the reason in second on the right side. And on this one, it's just switched, so we're kind of working backwards. So we're going to go through each reason and find the statement that goes with it. So starting with number 1, the first reason is that it's given. So we need to figure out what information is given to us. Normally we have kind of a list of things that are given, like when our proofs problems pop up, it's given, such and so, and then it asks us to prove something. We don't really have this in the problem, so we just have to look at what is labeled on the diagram. So as far as what's labeled on the diagram, we can see that this segment or that side is congruent to that side, and then this angle is congruent to this angle. So we need to figure out what of these statements is saying that. So it would be side or segment HI is congruent to segment KL, and then angle HIJ is congruent to angle LKJ. So that's this one right here. It has both of those together. So we would put this one with reason number 1. And then for number 2, or reason number 2, it says that vertical angles are congruent. So we have to look at, okay, what statement is trying to claim that vertical angles are congruent. So we have to look at what are our vertical angles in this problem. We have HJI, that's this angle right here. And then we have LJK, so that's the other side of it. So we have to look at what statement is trying to say that those two angles are congruent. So that would be HJI is congruent to LJK, so that is, all these letters are very, very similar. Looks like right here. Let me make sure I got the order correct though, because it's a lot of the same, almost the same exact thing written. So it was supposed to be HJI, so HJI, and then is congruent to LJK, LJK. Okay, so I think we're good. Just gotta be super careful with those. Okay, so this was our statement number 2. And then for number 3, the reason is angle side congruence theorem. So the statement that must go with it was must have been some sort of claiming that two triangles are congruent. And this one you can kind of take a little shortcut on. So we're trying to prove that these two triangles are congruent. That's our end goal, and we're at the end of the proof. So triangle HIJ is congruent to triangle LKJ. That's got to be the statement that goes with our final reason. So triangle HIJ is congruent to triangle LKJ. So that goes with reason number 3. I'm looking at, I know this one looks really similar too. I'm assuming, but I'm going to double check that I think the order is just mixed up, because the order matters. We have to keep the corresponding parts in the same placement. So if we look at, what's the first angle in each one, H and K. So that's saying H and K are corresponding. They're not, because the triangles are kind of reversed from each other. So you can kind of see it with the angles, how the angles are on opposite sides. So this vertex that corresponds with the H is actually L. So both the H and the L should have been first in the order, and that's why both of these were first down here in the correct response. Those H and L go together. And then the next one was I and K, those go together. Those were even like attached to the two like corresponding angles that we knew were congruent. So next was the like I and K. And then J and J go together because those were the vertical angles, so J and J were together as well. Okay, so for this one right here that looked really similar, it just was out of order. So just have to make sure the corresponding vertices match up as well. Okay, moving down to, oh, I realized it kind of late. This is 16.1, number 2. But you probably realized that. Okay, or just maybe didn't even notice it. Either way, it's 16.1, number 2. Okay, so 16.2, 16.2, number 1, Lena wants to place a triangular design element into a table she's building. What additional information is needed for Lena to use the hypotenuse leg congruence theorem to prove that triangle GHJ is congruent to triangle IHJ? So GHJ is that top triangle, IHJ is that bottom triangle, and she's trying to use the hypotenuse leg congruence theorem. So hypotenuse leg congruence theorem, it only works for right triangles because right triangles are the only ones that have a hypotenuse. So we have our right angle, so that's good. Like these are both right triangles, and then we need the hypotenuse. We need a leg. A leg is just like a side that's not the hypotenuse in a right triangle. We need those to be congruent and corresponding to be able to prove. So if we look at, we have our right angles, like I said, that's good. And then we also have this like side right here, which is a leg because it's not the hypotenuse. That's congruent because it's like a shared side. So using like the reflexive property, we could always say that segment HJ is congruent to itself. So now we just need the hypotenuse to be congruent. So the hypotenuse is always the longest side of a right triangle. It's also the side that's opposite the right angle. So on the top triangle, it would be GJ. And then on the bottom triangle, it would be IJ. So that's the missing information that I need. So for like hypotenuse leg or HL congruence theorem, we of course need like the right angle, and then we need a leg that is congruent and corresponding. So we have that with the HJ. So the only thing that I'm missing is the hypotenuse. So that's the thing that we need to pick, is the one that represents that the hypotenuse is congruent to the other one. So on mine, that's the fourth option. So GJ, that was the hypotenuse on the top triangle, is congruent to IJ, that's the hypotenuse on the lower triangle. Okay, I'm going to go back and just kind of like through each of the other answers, kind of explain why they don't quite work. So for the first one, it says that GH is congruent to IH, so that's like both of the like two left sides or left legs. We already have one leg. We have HJ, so for hypotenuse leg, you need one leg and one hypotenuse. So it doesn't do us any good to have a second leg. And then with hypotenuse leg, you just need the right angle. Like that's the only angle that you need for the theorem to work. We have that already, so we don't need any more angles. So the second and third option would be unnecessary also. So just need the hypotenuse in this case. GJ is congruent to IJ. Okay, moving down to 16.2, number 2, another proof. This one is like a regular proof, so it's not like backwards like the one in 16.1 was. So use the diagram and the information to complete the proof, given that triangle WXZ and triangle YXZ are right triangles, and also that segment WX is congruent to YZ. Prove that angle YZX is congruent to WZX. So let's just kind of point out like what angles we're trying to prove are congruent. So where's my YZX. So that'd be this one right here. It has a Z in the middle, so the Z is the vertex. And then it's congruent to WZX, so Z in the middle, Z is the vertex. So I just want to prove that those two triangles are congruent. Or not those two triangles, excuse me, those two angles are congruent. Okay, so starting with 1 just relists all the stuff that's given to us. You know, segment WX is congruent to segment YZ. And then the like triangle WXZ and triangle, YXZ, a lot of letters, are right triangles. So since it's given, our reason is just that it's given. Okay, number 2, I'm gonna kind of sort these two with highlighter in case that helps in any way. Number 2, segment XZ is congruent to segment XZ. Anytime you have something that says it's congruent to itself, that is the reflexive property of congruence. So 2 would be reflexive property of congruence. Things like reflexive, reflection, like looking in a mirror, it gives you like the same image back to you, and the object is congruent to itself. Okay, so far what we have is that WX and YZ, those are congruent to each other. And then we have the right triangles, that was given to us as well. And then now, like our most recent statement is that ZX is congruent to itself, or XZ is congruent to itself. So we have a hypotenuse of each triangle. Like if you look at kind of the upper left triangle and the lower right triangle, XZ is the hypotenuse of both. It's the like side that's across from the right angle in both. So we have enough information to do hypotenuse leg, because we have hypotenuse that's congruent, a corresponding leg that's congruent. So that's enough to say that like the two triangles are completely congruent by the hypotenuse leg theorem. So 3 would be hypotenuse leg theorem. And then once we like say that the triangles are congruent, like with whatever congruence theorem, then we can say that any of their corresponding parts are congruent, which is what we need to do to say that these two angles are. So next we can say that angle YZX, so YZX, that was this one, and angle WZX, that was this one. We can say they're congruent because corresponding parts of congruent angles are congruent. I think that's a typo. I'm pretty sure it's supposed to say triangles. Like parts of angles wouldn't really make sense. But in your workbook, I think it says triangles, so it should be corresponding parts of congruent triangles are congruent. The angles and the sides are the parts. Okay, so 1 was given, 2 was reflexive property of congruence, 3 was hypotenuse leg congruence theorem, 4 corresponding parts of congruent triangles are congruent.